Hello, fifth grade. Today we're going to go over 6.8, which is the power of jet propulsion. Now, I'm going to go over a couple different things with you, and one is going to be about the prop or propeller plane, then the turbojet, the turbofan, and the turboprop, and the ramjet. So I'm going to break it down into just a little bit of explanation for each of those so that you can learn a little bit more about jet propulsion.
Thrust force makes an airplane move forward. To produce this thrust, a turbofan engine is used in modern civil aviation aircrafts. Reaction force of high-velocity exit jet gives the turbofan engine the thrust force. To produce this high-velocity jet, the incoming air is passed through a compressor, combustion chamber, and turbine stages. The engine also derives the thrust force from the fan's reaction. Thus, the turbofan engines produce a great amount of thrust and make the airplane move forward.
Have you ever wondered how a jet engine works? It's a lot simpler than you might think. I'll explain the magic coming up. By General Electric. As you can see from this picture here that I took while I was doing a walk around on 747-8, you can see there are a lot of different fan blades on this engine. Today, I'm going to explain this core section here. All of these dividers that you see are actually fans. And these fans are designed to suck and compress air. And at each stage, they are compressing the air more and more. If you've ever put a piece of paper on the backside of one of your home fans, you've seen the fan actually hold that paper against the fan. It's the exact same design, except a lot stronger. These fans are designed to suck in a lot of air. So each set of fan blades is sucking in and compressing a huge amount of air. And actually, one of the reasons that we turn on our beacon before we start our engines is that there is so much suction coming from these engines that if a person was walking in front of it, they could be sucked into the engine. And that would definitely ruin your day. This massive amount of air is pushed into this canister. This canister is getting sprayed from all sides by fuel, kind of like this picture here. Imagine the bottle is the canister, and all these toothpicks that you see are fuel nozzles spraying fuel into this canister of highly compressed air. The thing that you're missing is a spark to make an explosion. When you introduce a spark into that canister, it creates an explosion. That explosion goes out of the back of the jet engine, and it does two things. One, it pushes the aircraft forward, which makes it a jet engine. And if you introduce more gas, you have a larger explosion, which allows you to push the aircraft forward faster. So now you know that the first stage, the air is getting compressed. In the second stage, that compressed air is being introduced with fuel and a spark to create an explosion. So we've already covered the first two sections of this engine. Here is the last part of how this engine works. These fans that you see at the back part of this engine, they work like a windmill. Your standard windmill that's sitting on every hill, when the wind hits it, the blades start to turn. It's the exact same concept, except when the explosion goes out the back of the jet engine, it turns those fans. And you'll notice that these fans are connected to a shaft. That shaft is actually designed to drive the fan blades on the front of the engine, which are sucking and compressing more air in. So as the explosion goes out the back of the jet engine, it turns these fans here, which then turn the fans on the front side of the engine to suck in more air. And more air is now getting sucked in and compressed and into this canister. So unless you stop the airflow, the fuel, or the fire in the canister, the engine will continue to run. Those are the three main parts of how the core of a jet engine works on your typical commercial aircraft. And if a jet engine was to be by itself, it technically would be called a turbojet engine. Engines of a turboprop work based on the exact same core principles of what I explained earlier on how a jet engine works. Here is the inlet of where the air is going into the engine on a jet stream, and this is the exhaust section where the air is actually leaving the engine. So the first two stages of this engine work exactly like a turbojet engine, which I explained earlier. The difference is when the air is actually going out the back of the engine, it doesn't use air to propel itself forward. What it does is it turns these additional fans in the back. These fans are on a separate shaft that drive the propeller on the front of the plane that you're seeing. So instead of air propelling you forward, the air is driving these fans, which is driving the propeller, which is pulling the aircraft forward. Turbofan is generally what you're seeing on most commercial aircraft. If you've flown on a Boeing or if you've flown on an Airbus, you've flown on a turbofan aircraft. This is a diagram of the turbofan that you see on most commercial aircraft. Side by side, this section of the diagram is actually this section of the engine that you see, and this section of the diagram is actually this section of the engine. This large fan that you see on the front of the engine is working exactly like a propeller on a turboprop. And this section of the engine is working exactly like a turbojet. So it's getting the best of both worlds. As the air is leaving the back of a turbine engine, it is driving the fans that compress more air. It is also driving this fan on the front just like a turboprop, and it is propelling the plane forward. So as that explosion goes out the back, it is pushing the plane forward and driving two different sets of fan blades to suck in more air and use that front fan as a propeller. The air from the propeller on the front is going outside the core of the engine, and it's making a much more fuel efficient engine, especially at lower altitudes. This type of engine is called a turbofan engine.
Jet, or ramjet, is an extremely simple construction with no moving parts. It is the most simple airplane motor imaginable. All it consists of is a cylinder with a distributor placed at its entry to compress the incoming air. Heat is provided by fuel injection, and the exit nozzle at the rear releases the burnt gas. It has been used in several experimental aircraft, notably the Griffon and the Leduc series. It only functions at high speeds, up to Mach 9, so these days its principal use is to propel cruise missiles.